Example 2 says estimate the value of the expression 3 over 1 minus x all squared at x equals 0.05. To do that, we want to choose a point of tangency close to 0.05. So it asks us to find a tangent at x equals 0. Now, to write the equation of that tangent line, I need the y coordinate as well. So when I plug in 0 to that expression, I get y equals 3. So then, to get the tangent line equation, I need to first of all find the derivative so I can find slope. So f prime, so I'm going to use this power rule for this. So I'm going to end up with negative 2 times 3, which is negative 6, 1 minus x, negative 2 minus 1 is negative 3, and because of that extra negative in front of the x, I need to use chain rule and multiply by negative 1. So simplifying this, negatives cancel out, and I end up with 1 minus x. That negative 3 becomes cubed in the denominator. So there's my derivative. I need to find the slope at 0. So plug in 0. My slope is equal to 6. So there's my equation, there's my slope. So the equation of my tangent line is going to be y equals, I'm going to use a slope of 6, and my x coordinate is 0 in my point slope form plus 3. So 0, 3 represents the y coordinate of that tangency. And then for the approximation then, what I want to do is I'm going to say that the f of 0.05 can be approximated by the y equation at 0.05. And when I plug that in, I get 6 times 0.05 plus 3. And so my approximation works out to be 3.3. Okay, so the point on the curve of 3 over 1 minus x squared can be approximated by the linear equation, and I get a value of 3.3. Okay, so what does this look like? Okay, we're going to sketch the curve, and it's going to look like this. My curve is going to be a reciprocal function. So it's going to be a curve like this, and our asymptote is going to be a positive 1. Okay, so I'm going to draw an asymptote at plus 1. And it's going to be curving something like that, and curving something like that. Okay, and at x equals 0, we have that coordinate that our tangent line, and this point of tangency generates a tangent line that looks something like that. Okay, now the slopes are a little off, but that's essentially what it looks like. So this curve is concave up at that point. So I can identify that the concavity there, it's concave up. And we want to be able to determine whether it is an underestimate or an overestimate based on that concavity. And we can see that our linear approximation value is going to be a little bit below. So at 0.5, I'm just kind of exaggerating this, but linear approximation is below that the actual curve on the black line. Okay, so we're going to make our conclusion here based on the concavity. This is concave up. So our linear approximation is going to be an underestimate. Okay, so this is underestimate. And we could also make that conclusion then that if the concavity switches, okay, so if I had a negative concavity here, we can see that that tangent line, let me just draw that tangent line again. So that tangent line is going to be now an overestimate. And it's to do with the concavity. So here we have a negative concavity, and we can see that that becomes an overestimate, and for concave up, we end up with an underestimate. Okay, so that is a property that we're going to start using to determine whether our linear approximations are over or underestimates. In the next example here, we're going to approximate value of log 1.5, and we're going to use a linear approximation at x equals 1. Okay, so if I sketch this curve, we know that there's a vertical asymptote. It's going to go through 0, and it's going to start curving off like that. Okay, so maybe I'll just change that up a little bit. It's going to look more like this. It's going to go through the 0 like that. Okay, so we're going to have a curve something like that. I need to make that more like an asymptote. Okay, so it's a little bit difficult to do, so I'm going to just freehand this. Okay, so there's our curve. There's a log x function, and it's going to pass through 1, 0. And we're going to use this tangent line at 1, 0. So I'm going to draw my tangent line through that point. Okay, and that tangent line is going to approximate a coordinate at 1.5. So again, the first thing I want to do is I need to find the x and y point. So at x equals 1, y equals 0. That's my point of tangency. I need a derivative. So the derivative of log x is going to be 1 over x. And we want to find the slope at that point, and we end up with a slope of 1. We come up with the equation of the tangent line. So y equals 1 x minus 1 plus 0. Okay, we don't really need the plus 0 in there, but I'm going to put it in just so that you can see that that 1 and 0 came from the point of tangency. Okay, so that's going to be that coordinate there. Okay, so there is my linear approximation line. I'm going to say that log 1.5 can be approximated by the y value on that function at 1.5. That's going to give me 1 times 1.5 minus 1, which is equal to 0.5. Okay, so my linear approximation is going to be at 0.5. The actual value and we can see by the curvature being concave down, we know that the red approximation is too high. The actual value of log 1.5 from my calculator ends up being 0.405. Okay, so that is an overestimate based on the actual value on the black curve.